All right, so we're revisiting the same story problem that we explored already about people who are trying to quit, and we had two groups. One group used a nicotine patch and met as a support group. Another group only used the nicotine patch. This time, instead of a hypothesis test, we're going to go ahead and create a 95% confidence interval. So I want to show you how similar this is going to be. All right, so step one in a confidence interval is to check conditions. We don't have to write hypotheses because it's not a hypothesis test. So first thing we're going to do is check conditions. Now, very convenient, conditions are the same in a hypothesis test and a confidence interval. So what we really should do is just notice that for this particular example, we've already checked conditions. Now, you could simply copy these down as step one into your confidence interval. We verified that the sample had randomization. The two groups were randomly assigned. We noticed there were two different sample sizes, group 1, group 2, but they were both less than 10% of all the smokers. And the last thing we did was we checked our NPs and NQs. In this case, we have to go with NP hats and NQ hats because all we have is our sample data. So we went ahead and checked all of those. Remember, there's two groups, so we had to do NP and NQ twice. And we noticed they were all greater than or equal to 10. All right, so conditions, we already did. Hurrah. And instead of a 2 proportion Z test, we're doing a 2 proportion Z interval, okay? Because we're creating a confidence interval. All right, so let's move on to something that's different. All right, so our mechanics. Pardon me, this should be a P hat. So this one should look familiar. This is what we did back when we just had 1 proportion. So the difference is that now we're doing 2 proportions. And remember, we're doing 2 proportions. It's the difference of 2 proportions. So I'm going to replace that P hat with P hat 1 minus P hat 2. So instead of 1 proportion, I'm doing the difference of 2 proportions. I'm still going to add and subtract some Z star times some standard error formula. Okay, well, whatever that is. Okay, so instead of this, we've moved on to 2 proportions. All right, so let's go ahead and fill in at least some of these things. We know P hat 1, we calculated that. I'll just remind you back when we did the first story problem, or the story problem the first time. Here's our P hat 1, 0.322. Here's our P hat 2, 0.199. So I'll go ahead and put those in for us. So 0.322, I'm subtracting 0.199. I'm going to add and subtract Z star. We're still in a normal model, so for 95%, we've got a Z star of 0.196. If you do not recall how to find this number, please revisit Chapter 19. The topic was critical values. All right, so the only thing left to do is to put in our formula for the standard error. Now, you're going to be slightly disappointed here. Here's what we were talking about last time. I presented you this formula. It looked kind of like what we did for Chapter 19 and 20. Just for 2 groups, and I added them together. On our hypothesis test, we pooled the results, and we used this standard error for the pooled. Okay, and we used all these pools. We did that because we believed the 2 proportions were equal. In a confidence interval, we don't think they're equal. That's why we're building a confidence interval, an interval for the possible differences. So we only do this for hypothesis tests. Okay, it's very important. Stick that in your brain. We only pool for hypothesis tests. That means for confidence intervals, we're going to use this one that's kind of a little more straightforward. Okay, so it's the P hat 1, Q hat 1 over N plus P hat 2, Q hat 2 over N2. All right, so that's what I'm going to go ahead and use here for my standard error. All right, so it's P hat, square root. Let's not forget the square root. P hat 1, Q hat 1 over N1 plus P hat 2, Q hat 2 over N2. Whew, that's, again, this is a little bit of a beast to calculate. So it might help if you go ahead and just kind of chunk this up a little bit. Maybe do this subtraction. It's 0.123 plus or minus 1.96. Maybe go ahead and do this huge, long, disgusting, awful square root thing here. Comes out to be 0.051. By the way, only because we're rounding is this the same standard error that we did in the hypothesis test. That shouldn't happen. It will very rarely happen. Coincidence, okay? For those of you who noticed. All right. And when I go ahead and run these numbers through, I get 0.02304, comma, 0.22296. Now, how many decimal places do you want to go? It's totally up to you. I'd at least do 3. I do have quite a bit of a range here. And that's my confidence interval. This interval represents the difference in proportions. So how much higher did group 1 do versus group 2? Okay. Remember, that's a difference. So the last thing, of course, that I would need to do is to write this in a conclusion. So I might say that I am 95% confident that the proportion of people who stopped smoking with a support group. Okay. Remember, I did the difference, P hat 1 minus P hat 2. So I'm talking about P hat 1 first, okay, because I put it first. So the proportion of people who stopped smoking with the support group is between, here's where my interval comes in, 2% and 22%. Yeah, I'm rounding a little bit here. Higher. By the way, how do I know those are percents? Because I'm doing a proportion problem. Okay. Higher than what? Well, then the group 2 people. Then the proportion of people who stopped smoking without the group. All right, so notice between 2% and 22% higher. 0 is not in there. That means the support group definitely did better. How much better? Well, between 2% better and 22% better. All right? So again, we've shown that having a support group is helpful. How helpful? Well, between 2% and 22%, more people stopped smoking. So that gives us kind of an idea of how beneficial it was.